Hello. This video will explain how and why you should create a sandbox lab environment. With all the security concerns we have today, your IT department will be very nervous when rogue devices like Raspberry Pis suddenly appear on the network. The IT department will be worried about who is using the device, what's its purpose, who is in control of it, and is it performing some evil purpose. IT departments want to be able to control how you connect to the network, how you log in, with Radius, with WPA2 Enterprise, or with single sign-on, and what type of security and operating system you're running. Most networks will block such devices or at least alert someone about the intrusion. Because of the amount and type of traffic this course generates, I strongly suggest for you to set up your lab so it isolates your devices from the rest of your school's production network. Every school I visit is apprehensive about letting Raspberry Pis on the network as they should be. Sandboxing allows you to run your Raspberry Pis without having your network administrator looking over your shoulder and questioning your motives. The solution is to isolate your devices in a sandbox or private closed network. This can be done with wired connections, my preferred connection, or wirelessly. Wire connections required switches and cabling to set it up, while wireless requires an access point able to support all devices at once. Both examples require a router with 2 Ethernet ports, preferably gigabit ports. The router will be programmed to use a private internal network and a public external network. PAT or port address translation will be used to exchange addresses between the ports. This way you can run your network as you see fit, while the world outside your classroom only sees a single connection. I use this topology for my sandbox. I purchased inexpensive 5-port switches to connect 2 student PCs and 2 Raspberry Pis together. I always have students work in teams of 2 even though they complete the labs individually. Those small switches connect back to a larger switch, which then connects to the router. This scenario cuts down on the amount of cabling you will need and makes it easier to leave everything connected when you're not using it. While any router will work, I use an inexpensive Cisco 1941/K9 router. It has 2 gigabit Ethernet ports giving me a fast connection speed, and it is able to run DHCP services, PAT, and simple security with ease. You only need one hard-wired connection to your school's network or internet service provider and one wired connection to a switch and all your internal devices. You do not need to run any routing protocols but instead use just a default route. The router will provide its own DHCP with a private IP addressing scheme and convert all traffic using PAT before exiting our router. Your network will only see the one connection, so that doesn't send up any red flags. This is a basic router configuration you can use to isolate your sandbox. The basic settings are turning on and off several services you might need. The Network Time Protocol, NTP, sets all the devices' time to the national time clock and then sets your current time zone. This allows all your devices to receive the correct time. This section secures the management interfaces so no unauthorized access is allowed. Note the username will be Netacad and the password will be class. You can change them as you see fit. This section sets up the router interfaces, assigns their IP addresses and defines the internal and external ports for NAT. Interface Gigabit Ethernet 0/0 is used to link to the internal sandbox and devices. Interface Gigabit Ethernet 0/1 connects to the outside world or your school's network. Gigabit Ethernet 0/0 is configured as the internal NAT interface while Gigabit Ethernet 0/1 is configured to be the external NAT interface. Note Gigabit Ethernet 0/1 will receive its IP address information from the school's DHCP server. This section sets up the DHCP server. It defines the network, subnet mask, default gateway, and DNS server information each device will receive. The excluded addresses define which IP addresses cannot be assigned. I reserve the first 9 IP addresses for my own use and the last 155 addresses are reserved for expansion. This allows 80 devices including all Raspberry Pis and student PCs to obtain an IP address. You can vary this as needed. One optional step is to map IP addresses to device MAC addresses, effectively making the device IP addresses static. This forces your Raspberry Pis to receive the same IP addresses every time. You will need to know the MAC address of the device for this to work. You can find this by using the ipconfig/all command from the command prompt of a Windows PC and the ifconfig command on the Raspberry Pi. The devices use a different format than the router. The device uses a semicolon while the router just uses a dot. The 01 added at the beginning of the address designates this connected using an Ethernet connection, while the remainder of the address is the MAC. You will repeat these 4 lines for every device, changing the pool name, the host IP address, and the MAC address. This section defines where traffic destined for the Internet will go. The Access Control List, ACL, defines which addresses are allowed to use NAT and exit the network. The final line saves the configuration in case of power loss. I think you will find the sandbox scenario very helpful when dealing with your IT department. A single connection will not alarm them and give your students the necessary rights to successfully complete the labs. If you would like a copy of the router configuration, please check my website. If you have any questions, please feel free to contact me.